Welcome to Six Sigma Black Belt, Course 4, Module 2, Data Collection. This module will go into great detail on the role of data collection and methods. Previously, there was some discussion of these ideas as part of our investigation into the voice of the customer. Data obtained from the customer is predominantly qualitative. Here, we will be considering data that is quantitative. From a customer standpoint, data is mostly subjective. Such data is typically qualitative. From the optics of a quantitative lens, the data will be objective such that consensus can be easily reached. Collected data with a known means of measurability is important. Data can be attribute, variable, or locational. Attribute data is discrete data. The best example of discrete data is the countable numbers, but there are many other examples. The clear distinction for a discrete data set is that there are no definable values between two adjacent values in the data set. For example, the number of children living in a home can be 2 or 3, but there is no definable value between 2 and 3. So this would be an attribute measure. Variable data is continuous. Continuous data can be meaningfully measured at any precision. Examples of continuous data include height, weight, distance, and volume. Measured data is regarded as being better than counted data. It is more precise and contains more information. Collecting measured data is often difficult or expensive and requires extensive planning and organization. Location data is not attribute or variable data. Location data indicates where. A defect map is a great example of locational data. In defect mapping, we seek to understand where issues are concentrated on the part. This can be highly informative in businesses such as the auto industry, carpet industry, or in kitchen cabinets. Sometimes we can transform attribute data into variable measures. Ultimately, our choice comes down to who is collecting the data and how it is being collected. Skilled workers using automated measuring systems would be great environments for exploring using variable measures for attribute data. In situations where the workforce is less skilled and/or manual data collection is in use, attribute data is likely the best approach. An example of this transformation would be in terms of the number of plywood boards exhibiting delamination. Delamination is the separation of the plies of the board due to insufficient processing or glue. This would be a go, no-go attribute parameter consisting of the number of boards with delamination. On one hand, if we wish to understand more about this condition, we could devise a tool to measure the strength in pounds per square inch of the plies of the board. Granted, this would be far more time-consuming and destructive, but it would help us gain useful insights into the integrity of the board. Clearly, there can be some significant trade-offs when moving from attribute data to variable measures. Make sure that the benefit is not outweighed by the costs when making these choices.